Hello, Sally. Thank you very much for taking your time to join me today. At NetZeroCompare, our audience includes industry professionals, consultants, and decision makers working across the energy transition. Your background in meteorology, energy trading, forecasting, and your current role as co founder and director of energy and weather operations and Decent Energy gives you a unique perspective on how weather data, and market behavior intersect. So, my goal today is to explore how weather intelligence can improve energy market operations, how traders and system operators can better respond to volatility, and what this means for organizations planning, for example, decarbonization strategies. So let's dive in. To start, if you could walk us through your career path, how you moved from meteorology into energy trading, and eventually into founding Decent Energy.
Yeah, sure. So thanks for having me. So I started with, I love geography. I always loved geography. So I did an undergrad in geography and finished that. And I felt like I wasn't sure what I wanted to do, but I'd always loved meteorology. So I went on to do a master's in meteorology. And from then I ended up at Meteor Group as a shift forecaster, which probably until this job has been my favorite job of all time. It was a brilliant bunch of people, but I couldn't hack the 12-hour night shifts after a few years of doing it. But whilst I was there, I got into programming and doing weather analysis. So moving to Centrica and sitting on the trading desks as a meteorological and data scientist worked really well. And I stayed there for another 5 years until I had my daughter. And then unfortunately, due to COVID and lockdown and things, my role was made redundant whilst I was on maternity leave. And I ended up in a role that was interesting but didn't fulfill me. And I reached out to Tom, who I'd met at university, because he was advertising a role, and he said, "Oh, this role's not for you, but I have an idea." And that's how Decent Energy was founded. So Tom came up with the original idea, and then I've been helping him develop it originally in my spare time. And then a year ago, I finally took the plunge and took it on as my main role. So yeah, it's been an interesting career. I don't think I knew I'd end up here, but I always knew it'd be something to do with helping the planet.
I need to admit that we have something in common because I always loved geography as well. And then I was thinking, what could I do in the future as an adult?
Yeah, exactly. It's great being able to observe the environment around you and things like that and see it from a geographer's perspective, but actually how to help the planet without being actively gardening and things like that is quite hard. So yeah, I totally understand that.
Agreed 100%. Decent Energy describes itself as weather intelligence and forecasting company helping organizations make better decisions in power markets. So, how do you define the company's core mission and what problems are you solving for clients?
Yeah, so I'm not quite sure where you got that full definition from, but we are basically renewable energy is not dependable. As we're doing brilliant as a country moving to more renewable energy, but what we're not doing is managing the demand. So obviously with solar, when it's sunny, we get an influx of energy. When it's windy, we get an influx of wind energy. That kind of comes in peaks and troughs. So what we're doing is to decarbonize demand. So we're giving everyone access to energy at the lowest possible cost in turn for reducing their carbon intensity at the same time. So whilst we're saving people money, which is what everyone needs with the way the economics are at the moment, we're also helping to reduce their carbon footprints. We're maximizing renewable energy at times of day when maybe renewable energy isn't high because we've stored it in batteries to use later in the day.
Perfect. Weather volatility now plays a major role in price spikes, imbalance costs, and operational risk. From your standpoint, which weather events or patterns are still underestimated by traders, utilities, or grid operators?
So I think the biggest thing I've seen, so I was actually working at Centrica on the trading desks in February 2018 when the beast from the east arrived with that very cold easterly wind, and we saw gas prices reach to the highest I think they've done possibly on record. And I think there's, sorry, there's always this slight fear that that could happen again. So whenever there's an easterly wind, there's those weather events tend to be wrongly interpreted by people who are not from a meteorological background because they're so worried that that's going to happen again. The other one I see a lot of issues with is fog and solar. Fog, I know for LNG can be a massive issue, but also for solar, sorry, it's a fog and solar. For fog, with solar forecasting, it's really tricky to work out when that fog is going to burn off and if it's going to burn off, or and the models are getting far better at forecasting fog, but there are still areas, and a lot of it's dependent on the ground type and things like that of an area. I'm in Surrey, where we've just got chalk everywhere, so there are local weather situations which people expect to clear and things like that, and now we're relying on more renewable energy and specific locations. There are issues there with those weather patterns that are more microclimate based having a bigger impact on the influx of electricity. I hope that makes
Hmm?
sense.
Yes, actually it does, and it's very interesting because also recently I read the piece that many still underestimate compound weather effects like heat, wind ramps, and cloud variability. So I think it's not the case at your company.
So we are only looking at solar forecasting at the moment, so it's slightly different because we're not a trading desk. So we're not looking at the forecasting of energy trading.
Okay, at all. And so that brings me to the next question. If you could tell us a little bit more about forecasting uncertainty, if you could expand on this. Because as we know, all forecasting comes with uncertainty. So, what are the biggest sources of error in weather forecasting, and how do you help clients interpret uncertainty instead of, let's say, relying on a single deterministic forecast?
So for us, particularly because we're forecasting solar, it's always those showers. Showers are always the bane of meteorologists' lives. They change whether they're getting bigger or smaller based on the time of year, the temperature difference between the land and sea. We need the highest resolution model you can get to actually forecast for them accurately. And things have improved significantly since I started forecasting in terms of the resolution of weather models, but you get one shower that sticks around longer than expected or gets slightly bigger than expected, or tracks slightly differently, and that can throw off your whole solar curve. And also it can affect the wind speeds as well, because you've got the updraft. You might find that there's suddenly a burst of energy near a wind farm. But yeah, for us, we rely on blended models. So considering multiple models, considering actuals as well. So we're constantly trying to improve the forecast and reduce that uncertainty. And you can include probability bands and things like that. But I think the way our tool works, we just need it. We do need that single line, but rather than just using one forecast, we're using multiple sources to create that forecast.
I think understanding uncertainty can sometimes be even more important than the forecast itself, right?
Yes, yes, for sure. I mean, that's one of the things I think any of the meteorologists on TV will tell you. It's explaining that uncertainty. Chaos theory is how the weather develops. Like if your butterfly flaps its wings in America, it could cause a storm over here, that kind of thing. Like it's never going to be 100% accurate. Even with AI and things like that, that's not going to happen. So if you can provide that uncertainty and make sure you're clear this may or may not happen, then that's key for sure.
As solar and wind penetration increases, forecasting errors can introduce significant costs. So, what forecasting innovations or analytical methods make the biggest difference, in your view, for operators managing high renewable shares?
So the grid is becoming more weather driven and less predictable because of that weather element and renewable energy. So there is a need for this. There is a need for us to bring in different ways of looking at energy, especially electricity. So numerical weather prediction, probabilistic, ensemble forecasting, higher resolution models are all key. And they're all advancing constantly. The Met Office example has some amazing supercomputers. You've got ECMWF and other weather providers. But it's also the element of translating weather into power. And if we don't have the correct algorithms for that, that's where we could end up with problems. We need to be able to go, right, this is the solar forecast, this is what we're expecting on this property or the solar farm. That translates to this amount of electricity, or the same with the wind turbines. And I think it's come a hell of a long way. Yeah, I think for me, the biggest ones are the ensemble forecasting and the probabilistic forecasting. And like we spoke about before, having different thresholds and looking at percentile bounds, that kind of thing. That's just important for this kind of thing.
Hmm. That's very interesting. Many of our readers work with PPAs, trading desks, and balancing teams, so I think they will find it highly relevant. And now I would like to talk about AI and machine learning that you've already mentioned briefly. So there is a lot of discussion, obviously, around AI and machine learning in forecasting. You've already mentioned that it will not ensure 100% accuracy and precision, but where do you see these tools truly adding value, and where should organizations be cautious?
So I think we are still learning what AI delivers and the real benefits of it. And I think it's that element of using AI as a tool, not so you don't say, I need it to do this. You go, right, this is what we need to do. Where could AI work with this? And I think there's lots of risks of assuming AI can do it better and quicker. And in meteorology, I don't think that will always be the case. Experienced meteorologists are always going to be crucial in certain weather events. I have worked with a numerous number of different meteorologists of different abilities, and there will always be different events where someone will go, I think that's going to happen. No model will pick it up, but that human eye has experienced it before. They can see the weather pattern and they catch things that the models don't. AI is really good, I think, for translating data into something that people can understand. So I think where we're trying to, particularly with renewable energy, explaining what's going on and why it might have an impact on the electricity market, for example, or the gas market, putting that data into AI and getting it to create a text that anyone can understand, I think that's where it could have its benefits rather than it actually trying to improve the forecast itself. It's kind of making it's using it as a translation tool almost, so that everyone can understand it from the same perspective rather than I've seen enough battles between traders and meteorologists where they don't agree on things. Like, you need to have that translation and understanding of each other. And I think that's where AI could support.
Thank you very much for that insight. Now I would like to talk about climate variability versus long-term planning. So climate variability is changing historical patterns, as we know. So how is this affecting long-term planning for energy companies, and how should organizations adapt their modeling strategies?
Yeah. So I remember when I came out of university, there was very clear weather parameters, weather scenarios, I guess, that you'd expect to have. Like, it'd be hot in these months, it'd be cold in these months, snow's more likely in these months. And those patterns don't really exist anymore. We see far more extreme events, and it's definitely less predictable from that perspective. So I think seasonal forecasts are becoming more and more important. If we can see the trends of what's coming, particularly how El Nino or La Nina affect the seasonal trends, that's really important for understanding what's going to happen long term. For example, there's been fewer hurricanes this year, but actually the increased strength of the ones that have happened has been far more devastating. But what I remember when I came out of university was if there was a hurricane in America, there was a good chance if it hit, it would track across and affect the UK. And now, because we're seeing fewer, we've seen far less stormy weather this year. Not completely that reason, but that's part of why it's been less stormy. And I think that's where it's changing the company's mindset so that they're thinking about this is what could happen. But if we have, again, it's like that probability side of things. It's we could actually have this worst case scenario, or we could have an easier scenario, and making sure that you consider both aspects, because those extremes are far more common.
Got it. Thank you so much. For people entering the energy weather intelligence space, what core skills or capabilities do you consider essential?
For me personally, I think it's understanding that we're all working towards the same goal of a better planet. You might not agree with how someone's doing something, or it might be different to your personal interests, but it doesn't mean it's wrong. And it doesn't mean that you can't help each other. We're working with a number of different companies, and we've been at solar and storage, and things like that with other companies who are looking at tracking elements or building batteries that you can put into rented accommodation. So you have no hardware to install, it's just a plug and play option. They're all related to the same as us, reducing carbon, helping the planet. But you it doesn't necessarily mean it's something I need or I want. And it's having that open perspective so that you can be so that you remind yourself that you're working towards the same thing. Like it's our kids and the next generation that are going to benefit from us making these changes, and especially with um, the removal of, for example, paper straws in America. Like that seems so small and insignificant to me in the UK because we haven't had plastic straws forever. But we need to make these changes, and if we keep making small changes and helping each other, then we're going to end up with a better planet. So that's my key thing.
Even from our personal standpoint, recycling at your own households probably makes a huge difference. If everyone would recycle, the earth would see probably a huge difference at the end. Now, I would like to talk about product execution and user adoption. So, you have experience as a project manager and product owner. How do you translate complex weather data into tools or products that traders, operators, or asset managers can actually use and trust?
So I can't really talk about that in terms of the traders and asset managers, but I can talk about it from Decent Energy's perspective and our customers. So Decent Energy, we have an interactive dashboard that every customer has, and we show everyone's carbon insights. So as well as seeing how much money you're saving, we're really key on showing the carbon you're saving, and we translate that into tangible items that every person can understand. The amount of carbon you've saved today is the equivalent of 8 plastic bottles or 6 cups of coffee. It's translating data into things that the everyday person can understand, because it's all good and well talking about carbon and your carbon footprint, but not everybody understands what that is or why it's important. But you say, remove this number of plastic bottles by just shifting when you use energy, and people start to understand it. They understand plastic bottles are not a good thing. We don't want to use them all the time. And it's changing, it's translating the data into something tangible that's the key thing. That's what's really important to me.
Plastic bottles are not only bad for environment, but also for our health, as we know. As we come to the end of our conversation, is there anything important we have not discussed that you would like to add, especially something that could be useful or relevant for our audience?
Yeah, I think the main thing I haven't spoken about is Shifter. So Shifter is our first product that is currently in open beta, and anyone in the UK with an inverter can sign up for it. We have a number of different inverter manufacturers already integrated with our system, and it's plug and play. It's the idea that you can help the planet without having to think about it too much. It offsetting when you charge and discharge your battery to make your day more environmentally friendly, and it saves you money. Currently, seeing we're about to hopefully launch a new version of the tool that could save you up to 50% on electricity bills, which would be massive if our numbers continue in the way they are. But we have to test it through different weather scenarios to be sure of it. But it's so easy to just sign up on decentenergy.io, have a look, and yeah, we love to have more customers signing up, and we will be coming out of open beta soon as well, which should be the real benefit. And our new products are launching next year.
So we encourage everyone to look into your website. We'll include the link afterwards as well, so it's easier for our readers to find it. Sally, thank you very much for sharing your insights today. This has been a very interesting conversation.
No problem. Thank you very much.